At HPC, this is Trig Notes number 4. Again, continuing on our review of Algebra 2 Trig so that we can spend some more time doing some calculus stuff, but just a quick review again. So we're looking at the unit circle, and the first question is saying, why is it called a unit circle? Well, it's called a unit circle because it's a circle with a radius equal to one standard unit. So everything is based off that hypotenuse of any triangle we draw being a 1. Now, right now, we're only using it as a radius around a circle, but remember, we're going to also include some right triangle trig in here as well. So if you look at this triangle that's already been drawn, you can see that in order to draw this triangle, we basically started at the origin, right? And we went this way a little bit, and we're going to call that amount x. All right, and then when we got there, we went up a little bit, and that would be called y. And that's going to end at a point on the circle that's called x comma y. And if we complete that triangle, we're saying we're going to scale that triangle so that the radius is exactly 1. So if we have this and we're using the numbers and letters x, y, and 1, what would be the sine, cosine, and tangent of this triangle? Well, it depends on where I'm standing, right? So one of the first things we do is we always assume that we're standing at the central angle, that is our viewpoint of the triangle. So if that's true, then sine is O over h, and opposite would be the y, and h would be the 1, or another way to say that is it's just y. All right, cosine is A over h, and again, if I'm looking from that central angle from the origin, then the adjacent side would be called x. The hypotenuse again would be 1, so that is an x. And then lastly, tangent, if I am looking from that central angle, tangent should be O over A, and O over A would be y over x. Okay, so that is actually going to work out being y over x. So there is a reason why we always put these three main trig functions in this order. Yes, it's going in the order of SOHCAHTOA, but also so that it's already set up to do tangent. So visually, if I find sine first, then cosine, then I just stack them on top of each other and I get tangent. Okay, so every coordinate on the x on the circle in xy is actually cosine of theta, sine of theta, assuming that theta is the central angle. All right, some other stuff is knowing what things are positive and negative depending on what quadrant you're in. So if I think about any points that I would plot into quadrant 1, I would be going to the right and I would be going up. Those are both considered positive directions, right? In the x, positive would make sense, going to the right, and in y, going up would make sense. So in quadrant 1, we have a positive and a positive for cosine and sine. Since cosine is the x, it's going right, that's positive, right? If I take a look at quadrant 2, now the x is going negative. So that's another way of saying cosine is x. And this one would still be a positive. All right, looking at the next quadrant, quadrant 3, I'd still be going left first. So that's a negative. And then down, that's also a negative. So that's going to be negative, negative. And quadrant 4, let's see, what color haven't I used yet, is going to be right. That's a positive. And then it's going to go down, which is a negative. So that is plus minus. So I should have every combination listed in there, right? That if I plotted a point wherever this point would be, I would have gotten here from going from a positive direction to a negative direction. Okay, and that's what the chart shows. All right, so if we are looking at that, then in quadrant 1, since sine is considered all the y's, in quadrant 1, sine is always positive. In quadrant 1, cosine is always positive. And in tangent, tangent is always positive because we're doing a positive over a positive, which is positive. So we can say in quadrant 1 that all trig functions are positive. If we go and we look in quadrant 2, okay, so this was quadrant 1. If we go and look in quadrant 2, now we have that negative that's happening from the x, and that's a cosine. So cosine would be negative. Sine would be the y value, that's still positive. So that's a positive. And now if I create tangent out of that, I would have a plus over a minus, that would be a negative. So we can say in quadrant 2, only sine and cosine are positive. only sine and just sine, right, is positive. Okay, then let's go and take a look at quadrant 3. So in quadrant 3, we said this was a negative x, so that means cosine is negative. And now we have a y, so sine is negative, and when you do tangent, negative over negative, hey, that turns positive. So now we only have tangent is the only one of the main 3 that are positive in quadrant 3. And our last one, quadrant 4, if I'm going x direction, that's positive, so that is cosine. If I'm going in the y direction, that is negative, that is sine, and if you put those over each other, you get negative. So the only thing positive in this one is cosine. How the heck are we going to remember this? Well, for people who are visual learners, it's just that easy. It's just thinking about if I were to put a point into that quadrant, which way would I have gone if I was graphing on a coordinate plane? For others, we have learned that there is a phrase that we could use to find, and this is again just for the main 3, right? To find where the 3 main trig functions are positive. So it's only a positive chart basically, right? And so the phrasing is starting in quadrant 1 is A, S, T, C, and that stands for all students take calculus. Okay, so that would mean that in quadrant 1, all 3 of them, cosine, sine, and tangent, are all positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. And that's going to also work for our reciprocal functions. So in our reciprocal functions, if you remember, the reciprocal of sine is cosecant, would also be positive. Tangent would be cotangent, so cotangent is also positive. And cosine would be secant. So all 3, so in other words, all 6 would be positive in the first quadrant. So secant, cosecant, and cotangent. All right, so it's an easy way. All students take calculus. You just have to remember that. All right, on to our next one. So in our next one, we're going to use some triangle problems. So we need to know 3 things. We need to know how to draw the triangle into each quadrant. We need to label all the sides of the triangle with the correct numbers and signs. And that hypotenuse is always 1. And then we check our answer against the quadrant. So we kind of do all the number work first, and then we go back to all students take calculus and put in the right sign. So we have to remember that when we're drawing a coordinate point, we always go in the x direction when we're plotting, and then y. So what that's going to create is our triangle. So when you start at the origin and you go left or right, that's already one side of your triangle. So your triangle should always be attached to the x-axis because that's the first position you would go. All right, so once we draw them all attached to the x-axis, right, I'd have one going this way maybe, and then this way and then back. So there's our right angle. I'd have another one going right and then up and then back, and there's a right angle. I could have one going left and then down, and there's our right angle, or I could have one going right and then down, and then return back, and there's our right angle. So it makes it look like a bow tie if you look at all 4 of those triangles together. Next one says, okay, let's label all 3 of the sides, which is pluses or minuses. All right, so that just means that this would be a plus, this would be a plus, and radius is always a 1, so it's also always a plus. This would be a minus and a plus, and this is a positive 1, so always a plus. On our next one, we'd have a minus and a minus, always a plus for the radius, and plus and minus, and always positive for the radius. Cool. All right, and again, those angles that we're using are always in the center part of the triangle. They're always kind of as close to the origin as you can get, so they're central angles, angles where the vertex is the origin. All right, so next part is, now that we know that those x's and those y's are giving us indicators on what kind of triangle to draw, now we can actually create the triangle that we want and do trig to it. So in the first one, we have -3, 4. So remember that the -3 is the x, which is also known as the cosine, and that's only assuming, and then the y is the sine, and that's only assuming if radius is equal to 1. So when I go and draw this triangle, I'm going to be going left 3, up 4, so this is definitely not to scale, right? Up to 4. And obviously the radius cannot be 1. The hypotenuse of a triangle is always the longest side. This is not a 1. Matter of fact, to do this one, I'm back to Pythagorean theorem. Negative 3 squared plus 4 squared equals c squared. So I'm going to get 25 equals c squared. So this is a 5. So that means I can no longer just say cosine is just the x because the radius is not 1. That only works if it's a unit circle, meaning the radius is 1. So now I'm back to doing SOHCAHTOA stuff. So if you want to know what cosine or sine is, my central angle is right here. So I'm basing everything off of that angle. So if I am looking for sine, it would be O over H. That would be a 4 over 5. And again, I'm not going to worry about sines right now. I'm just going to get the numbers down. Cosine would be 3 over 5. Tangent would be 4 over 3. And then we would just flip these fractions upside down for their reciprocal functions. So sine starts with an S, cosecant starts with a C. Those two go together. This is 5/4, 5/3, and 3/4. Okay, let's go get the sines right. So if I remember that all students take calculus and I'm in quadrant 2, that means anything related to sine is going to be positive, right? And that should be the only thing positive. So notice cosine is going to use that -3, so those are negative, and tangent's also going to be negative because it also has the -3. Well, and it's that simple. So we know it's not a unit circle, so we're going to go back to SOHCAHTOA stuff. All right, let's take a look at the next one. So in the next one, we are going -2 this way, and then straight down for -3. Right? Obviously not a radius of 1. Let's go figure out what that other one is. So 2 squared plus 3 squared equals c squared. This is going to be 4 plus 9 equals c squared. So we're talking about square root of 13. Okay, radius is positive though. That's still the same. All right, so again, I'm just going to worry about if this is the central angle theta, right? And I'm doing SOHCAHTOA, right? I'm doing O over H, so that would be 3 over square root of 13. And hang on a second, I'll go fix the 13s after, but let's just get them all. Then cosine would be 2 over square root of 13. Tangent would be O over A, that's 3 over 2. And then we're going to go do the reciprocals right away. And we'll notice that these first two do not need to get fixed in their reciprocal format. 13 over 3. So if we're in quadrant 3, all students take calculus, that means that tangent is the only thing that is positive here. Everything else is going to get a negative sign in front of it. Then we can go ahead and go fix these by multiplying by radical 13 over radical 13. And this is going to turn into -3 radical 13 over 13. This is going to turn into -2 radical 13 over 13, and the rest are okay. All right, let's try a couple more, make sure we've got this. And then the rest is just messing with the directions, but we're essentially doing the same thing. Is it a unit circle? Then it's just cosine and sine for x and y. If it's not, then we're back to SOHCAHTOA. So in this one, it's saying go right 7 and then go down 24. Again, obviously not to scale. And then to figure out this one, we've got 7 squared plus 24 squared equals c squared. All right, I'm going to definitely need a calculator for this one, so give me a second here. So we've got 49 plus 24 squared equals 625. That sounds like it's a perfect square. 625 is a 25. All right, so again, the 25 is positive. So we're not on a unit circle because the radius isn't 1, so we're looking at SOHCAHTOA. So O over H is going to be 24 over 25. Cosine is going to be the 7 over 25, and tangent is going to be 24 over 7. Because it's in quadrant 4, only cosine stuff is negative. Sorry, only cosine stuff is positive, and then sine, cosecant, tangent, cotangent are all negative. Okay, so flip these over, we're going to get 25 over 24, 25 over 7, and 7 over 24. All right, last one. Sometimes they won't even draw the picture. They're just like, tough, here you go. So you could always draw that picture, and the first thing we're going to figure out is where do I draw the triangle? So we're going to actually start out with all students take calculus. the first thing that we know is that tangent is negative. So if tangent is negative, let's go circle the quadrants where tangent would be negative. So tangent would be positive in 1 and 3. So tangent could be negative in 2 and 4. Okay, and then the other clue to narrow it down to exactly which one we are looking for is this one right here. It says cosine is positive. So cosine is positive here because everything is positive in quadrant 1. And then the other place where it's positive is here. So the only place where they overlap is in quadrant 4. So once we know that this problem is in quadrant 4, now I'm back to just drawing my triangle and saying we are doing a 5 and a 4, right? And 5 over 4 is supposed to be O over A. So if I am here in quadrant 4 and I draw just a typical triangle that looks like this, O over A looks like that. And one of those have to be negative. Well, which one is logically negative? The going to the right 4 is not negative. The going down 5 is negative. All right, and then lastly, we could go and find our remaining side again by doing 16 plus 25 equals c squared. That is going to be a 41. So this is square root of 41. Okay, and that's a positive radius. So then I'm back to just doing sine, cosine, and tangent that way. So now I'm looking at O over, well, I already know tangent is going to be negative 5 over 4 because they gave it to us. So I already can switch this one over this way. Right, and we already know cosine is the only thing that's positive, so I already know these two are going to be negative. And then it's just a matter of putting in the rest of them. So cosine would be 4 over square root of 41. This one is square root of 41 over 4. And then we have negative 5 over square root of 41 and square root of 41 over 5. And again, we would fix this one to be negative 5 square root of 41 over 41. And this one to be 4 square root of 41 over 41. Cool. Awesome. That's it for this one.